potential opportunities for transitioning to net zero emission?
Yeah, I think I think it starts with. I think it's a very eminent question because it starts with sectors where you have a very high level of emissions. Where we need to like manufacturing sectors like cement, steel, aluminium. Just to give you a perspective, they emitted 108 million tons of CO2 in 2023, making them one of the significant contributor to India's carbon footprint. HVAC systems which are efficient in these segments will help through technologies like heat recovery, variable speed drives in reducing emissions while maintaining the operational efficiencies in this segment. Also, I think we use scalable renewable energy integration in this sector, which will also help in reducing energy, like technologies like heat pump that helps in reducing the carbon footprint. Also, incentivizing the green innovation that also helps in this sector. Yeah, I think that's it from my end. Thanks.
Thank you for sharing your views. What are your views about it, Mr. Vivek?
So HVAC sector offers numerous opportunity for transitioning to net zero emissions, and some key potential can be as I mentioned in my presentation, also the existing buildings, the retrofit, which gives a greater amount of opportunity to reduce down our carbon emissions, because the buildings which are there from last 15-20 years, the technology was not that great at that point of time, and the design of the building and the material being used in those buildings, nowadays we have a very advanced material in terms of U values. So by retrofitting those buildings, we can really reduce down our carbon emissions to a greater extent. Apart from that, the very important thing which I believe is the public awareness and the education, which is very important to be given to all the sectors, because people usually, while designing the system, they design it for the very higher efficiency, but on actual when it comes to a practical scenario, that time we see that the uh, equipment are not able to deliver that much amount of energy for which they are already designed. So there should be some audit which the company should do, either the customer or the manufacturers should do at their end, so that they can see whether the systems are delivering for what they were actually designed. And if they feel that it is deviating from the design, so where is the area where we can help reducing down the emissions. Apart from that, we can have the collaboration with the different technologies, like the normal cooling machines can be clubbed with the heat pumps or the heat recovery machines, because usually in building, in most of the buildings, there is a requirement of hot water, for which customers use boilers or heaters, which can be easily replaced by the electrical machines which you are already using for the normal cooling. And the most important factor is the refrigerant, which is the hot topic nowadays, and it is very important that we also strive to what we have signed for. There is regulations coming in, because in the past also we have seen how the transition from HCFCs to HFCs has taken place. So it was decided for a longer time, but the transition had happened much ahead of the deadline. So it was, I believe, 10 to 12 years before the deadline, the transition happened. And the similar kind of fashion we would be seeing in the coming ongoing HFCs also. So it's better that now the equipments are there, so better that the education or the awareness can be given in the market, so that customer can also avail to the more sustainable product. Because if we go for the more sustainable product, then obviously the longevity of the equipment also increases. Then on the refrigerant management system, there is a huge area of lies on the recycling of the refrigerant, because when customer is replacing the equipment, what are they doing with the refrigerant which is already there in the equipment? So once that refrigerant goes into atmosphere, it is causing a emission, because that refrigerant, because of the higher GWP values, it remains in the atmosphere longer period of time, and the ongoing HFCs have the very long environmental atmospheric life, which is in the tune of 15 to 20 years. So that depends. So if once goes into atmosphere, they remains into the atmosphere for that long period. So there is also a long, huge area of recycling the refrigerant. That part also we can take into our account.
Thank you, Mr. Vivek, for sharing those highlights. And as you rightly said, so awareness, design, and the refrigerant is a big issue, which can solve many problems. Coming to Mr. Amit, what are your views about the opportunities for transitioning to net zero emissions?
Yeah, according to me, it's not one stakeholder's responsibility. As we have, like, it is the society's responsibility, I would say. It comes with all the stakeholders, like Mr. Vivek was explaining that um, the maintenance things and all. So it starts from thought process of the building, right, from the architects to the designer to installer and then again maintenance team. Because as a designer, we always see that the designer designs the system very efficiently, but it is the responsibility of all the stakeholders. Like I was explaining about the radiant itself. When we go with the radiant, it can save 30 to 40% of the energy compared with the conventional air conditioning system, which itself is a big value. Because in any building, if you see the power consumption requirement of any building, only 60% of that energy requires only for to maintain the conditions, which is air conditioning system. And in that, if designer decide to go with the latest technology which can save 40% of the energy, and addition to that, if we use the recovery or any natural aids to that, like earth tunneling, maybe solar energy, maybe wind energy, if we can club that, we can definitely, as a designer, we can reduce that. But it is the responsibility of next person whom we transfer that battle to, the installer, who should take care of that systems very, I would say, um, specific manner to deliver that in that fashion. Similarly, even after installation, we have seen many cases the major role plays with the maintenance guys. Because the building designer and installer will stay in building for say 3 or 4 years, but the maintenance team will stay in that building as good as the building life. So they will have to take care of every single component and maintain those components as per the design. Then only this entire circuit can be completed to achieve this net energy. This is what the my views are.
Thank you for sharing your views. Mr. Amit, you were mentioning about the radiant cooling systems in your presentations. So, why do I go to the retrofitting aspect? So, how to address the challenges in retrofitting existing HVAC systems with energy efficient technologies?
Yes. See, I have explained two radiant. I mean, radiant is not only the option where we can save the energy, to be very clear onto that aspect. Radiant is one of them I was explaining. But yes, even in, retrofit building, we can go ahead with the radiant also. This system is called as a low mass system. There also we can install the radiant. But apart from radiant, we can take use of the VFDs. The main part is the occupant. If occupants increase the temperature by 1 degree in the conditioned area, this awareness to be spread out in entire, I would say, the users. As we all know that there is specific relation between temperature and air. If temperature is higher and the velocity is if the temperatures are higher by 1 or 2 degree, but if we increase the air velocity, still we can feel more comfort in that area. So this awareness needs to be spread out in all the stakeholders of the or users. But there are many technology. Heat recovery is one of them. We can use the heat recovery to reduce the power consumption of the system. Even nowadays, ASHRAE is mentioning the specifications on the air pressure requirement. If you see, the ASHRAE to mention the airflow requirement of 7.5 CFM 5 6 years back, but now it is reduced to uh, 5 CFM. Earlier it was 7.5 CFM. So it is a reduction of say 2.5 CFM which is, in terms of energy, it is huge energy. If we work onto those aspects, and if we reduce pressure further, and if we concentrate on the uh, internal parameters, IAQ parameters of the building, still we can, go towards net zero.
Yeah, Mr. Amit. Thank you very much uh, for the specific reply to that. Mr. Vivek, coming to you, you were talking about the role of decarbonization and the growing demand, but the transition is also happening. And while mentioning about the refrigerants, how can the transition to low refrigerant transform temperature control systems to reduce HVACR climate impact? Mr. Vivek.
Yeah. So we can do it for the existing system as well as for the new systems. So there are technologies available in the market. If customer wants to retrofit the existing system with the lower GWP solutions, we can do that. But however, there will be some slight of energy drop and efficiency drop if the existing systems had to be done the retrofit. Reason being because the molecular mass of the refrigerants are different, the drop-in replacement and the ongoing existing refrigerant. But for the new system, if they decided to go for the low GW solution for the new systems, all those advancement being taken care at the factory level. And by using the low GWP solution, actually each organization is helping to reduce down their scope 1, scope 2, as well as scope 3 emissions, because whenever we have to submit our sustainability report, we have to give our scope levels 1, 2, and 3, how we are going to, how and how much carbon emissions we are going to reduce down. So it is not only helping the manufacturer, but it is also helping the corporates and the customers to achieve their sustainable goals. And the existing and the existing system, the new global low GWP solutions, they have a wider operating envelope. So with respect to the existing, so they deliver 5 to 6 times higher efficiency. It is not only the system. Environment is one part. It is beneficial for the environment, but it is also helping you to the reduce down your overall energy and your electrical expenses. Your direct emission, just in case there is any leakage, they goes into atmosphere, the atmospheric life is very less. Their atmospheric life is hardly a month, depending upon the type of molecule we opt for. Reason being, the new molecules, the low GWP molecules have double carbon bond, which when goes into atmosphere, they breaks down and they doesn't trap the heat. They nullify and they reflect the heat on the upper atmosphere. So that's how we reduce down our scope 1 emission. And because they have the 5 to 6% higher efficiency, they can also help you reduce down your scope 2 emissions. And over a period of time, because the new usually the capital equipments, they have a life of 15 or 20 years. The technology what being offered with the new refrigerants are way advanced. For example, for the larger size of equipment, let's say 1,000 tons machine in a building, so that 1,000 tons machine on the refrigerant which it will be operating, that machine will not have gears in it, so the gear transmission losses will be eliminated, and the load on the bearings will be very less, so the life of the equipment increases. And already you are giving 5 to 6% higher efficiency, and that's how the duration in the efficiencies will be lesser. So the longevity with respect to the existing system will be greater in case of the new technology with the lower GWP solution. So I feel that the opting for this thing will not only help as a nation to be on track with respect to the net zero, but it will also help individual organization as well as customer to save their expenses and help them achieve their sustainable goals.
That's wonderful. It would definitely help to achieve the sustainable goals. Coming to Mr. Rajarshi, you were talking about the net zero potential, predictive maintenance, and future sustainability aspects. So, what strategies will you suggest for maximizing HVAC efficiency in sustainable building management?
See, I think we spoke about this. We spoke about variable frequency drives. We spoke about zoned HVAC systems, use of automation. I think Johnson Controls is a key proponent of that. I think now the equipments are connected, equipments where information is being taken to the cloud, and actually compared with benchmark data, and then controls are sent back, so that to ensure the optimum usage of these chillers, equipments. Then also checking the health of the equipment on a regular basis to ensure that there is optimal usage. Then I think there's a lot of automation which has come in, building automation system, which helps in, because what happens is you have this HVAC which takes care of the guzzlers of energy, 60% of energy. Somebody spoke about that. As the energy is consumed by them. Now, when you do automation, 1 degree reduction in temperature is actually helping you save 3% energy. So I think all these actually helps in efficiency improvement, which helps the moment you save energy, you actually cut carbon emission, and that helps in your net zero goals.
That's great. Automation saves 3% energy. That should be awareness among the people.
I'm
Coming
talking
to
1 degree temperature reduction, temperature increase in reset, chill water reset will help. Usually what happens is when you put in a BMS system, the energy efficiency, the improvement is in the tune of 10 to 15% overall.
That's quite a knowledge. Thank you, Mr. Rajarshi. Coming to general question again. So what strategies would you suggest for the government or regulatory bodies should come up with to accelerate the transition towards net zero?
See, for that, I think we will have to define our targets in terms of energy usage, because this is not the activities will happen day or two, or maybe in a year. It is long term process of achieving net zero, because as we are saying that we have been discussing on 2070 target, but some of them started discussing 2040 or 35. So we will have to make a strategic plan